Okay. Good morning, everyone. So this is Zoe here from the SOC. Hopefully some of you might have started hacks already. I know myself, I just woke up this morning, so I will be starting hacking shortly. And hope you might have already seen, so Monica gave a fantastic introduction last night already, and you might have seen it already. It's all on the YouTube playlist, as well as Laura's SunPy talk, so do go and check that out if you haven't seen it yet. And I'm not going to bother repeat everything that Monica already said, but I will remind you of a couple of things. Also, the SOC are here to help you if you have any questions throughout the rest of the day. So we have people in, excuse me, in Australia, across Europe, East Coast, West Coast, USA. So someone's going to be awake and ready to to chat to you. If you have any questions, you can reach us on our contact information in the schedule. If you have a look at the schedule document, which is linked from the PyAstro20 Hack Day Index. And what else did Monica say? I'm just having a quick look at her list. Yeah, so she gives a lot of information. If you double check, they're linked to the slides. Her slides are in the index document. So she gives some great information about how the Hack Day works, how to get access to all the different docs, and how to create your own hack rooms if you want to. If you haven't already, there's plenty of time to start some new hacks. And we have the whole rest of the day. Don't be shy. Any and all hack ideas are welcome, and you're welcome to join other people's hacks too. And don't feel obliged to stay in the same hack for the entire day. You're welcome to hop around and find out what suits you best. So do add your ideas, and we would love to get a bit of an idea of who's kind of participating as well. It's always a little bit harder with remote participation to know who's actually contributing. So there is a sheet in the index. If you want to add, of course, your name to the hack ideas, that's great. There's also a sheet in the index of a bit of a participant list if you want to keep in touch with us in the future. So do add your contact information there if you're interested in that. And then a final thing I just wanted to remind people before we get started on the talks is the code of conduct. So everyone is required to follow the Python and Astronomy code of conduct, and that's up on the PyAstro website, and there's a link to that in Monica's slides as well. We want to make sure we have a positive, inclusive community, and everyone feels comfortable working with each other during the hack days. So do make an effort to welcome people into your hacks and answer and welcome questions. Please avoid shaming or bashing particular tech choices, even if it's in jest. If you have any issues with your experience here, do DM one of us. As I said, our contact details are in the PyAstro schedule, or just email the Python and Astronomy SOC, and we will get on that as soon as possible. So yeah, do network, use our Matrix channels and our Slack channels, and enjoy the hacking. So this morning we have a couple of talks. I'm just checking the schedule. So I think our first talk is going to start on the hour, if I'm correct. Someone please correct me if I am wrong. So at 10 a.m. Yes, so at 10 a.m. we'll have our first talk. So we have a good 7 minutes. So I'm going to wait just in case people want to join in the last few minutes, and then we'll kick off our talks for the morning. And in the meantime, if anyone has any questions for us about general hack day stuff, feel free to bug us now on the Jitsi, or the talk Q&As, of course, on Slack or Matrix. And I'm back. So it's now 8 a.m. UT time, so 9 o'clock in Dublin, and we're going to start our talks for the morning. So first up, Brett, are you there?
I am.
Perfect, and I can see your slides already, which is fantastic. So Brett is astrophysicist at the University of Bern and is a maintainer, I believe, of some Astropy affiliated packages and has lots of involvement in the open source development community. So Brett is going to give us a bit of an update to the Astropy project. So take it away.
Thanks so much for your introduction. I find myself in the peculiar situation of representing the work that a lot of you have done. And so I want to first say that I might be the one talking right now, but the Astropy project is so much bigger than the contributions of any one individual, especially me. And I'm honored and humbled by the responsibility of representing it before all of you today. The Astropy project, as you know, is one of the central community efforts in the astronomy community to create a package that solves problems for the average astronomer in as few lines of code as possible, as efficiently as possible. And I'm going to give you a brief overview of the Astropy project as a whole. In order to do that, I solicited some very helpful advice from Adrian Price-Whelan and Eric Tellerud, who are not presently speaking, but some of their talk advice and code will be used in this presentation, and so I want to take the time to thank them up front. So why Astropy? Astropy was necessitated partly because Python is becoming the de facto language of astronomy. And here's what I mean by that. If you look at number of mentions per month in the literature on NASA ADS, you'll find that Python has an ever-increasing share of the fraction of mentions in the astrophysical literature. And the reason for that is manifold. Python is free. Python is easy to install for some people. Python is accessible, docs-oriented, user-friendly, I think. And so Python is the language of astronomy, as far as I'm concerned. And then the next question might be, what fraction of the astronomers who use Python are using Astropy? And that might be hard to answer, but if we look at the number of citations per month on either or both of the two Astropy papers, we see that there is an increasing number of citations to Astropy per month throughout the year, every year, for the last 7 years since the publication of the first Astropy paper. And so just to place ourselves on that timeline a little bit, when is Astropy? Astropy was founded more or less in 2011 as a group of pre-existing and new astronomical Python tools. The first Astropy paper was published in 2013. There is a link to this talk in the PyAstro schedule, which has active hyperlinks on it, so you can access all of the links that are embedded within this talk. So there are links to those papers that you can click your way through to if you haven't seen them. They document the progress of the Astropy ecosystem and infrastructure. And the most recent paper was published in 2018 in the Astronomical Journal. And I encourage you to take a look at that paper, which includes many of the details about updates that have been made since you might have read the first Astropy paper in 2013, because quite a lot of work has been done between those two time points. And on this very nonlinear timeline, we have a new milestone, which we passed last year, which is that Python received its first major funding. Not Python, sorry. Astropy received its first major funding from the Moore Foundation in 2019, and I'll mention a little bit more about that in a moment. So what is Astropy? Astropy is kind of a lot of different things to different people. There might be one easy way to split our definition of Astropy, which is along lines of what you're importing in your Python scripts. We refer to the Astropy core package, meaning what you get when you import Astropy in a Python shell. And core package development is obviously a large fraction of what we spend our time thinking and worrying about when we contribute to Astropy. But there's also the broader Astropy project, which is the efforts to consolidate and reduce duplication of effort and increase modularity of Python packages around the core package. including the development of what are called affiliated packages, which are other Python packages that depend on Astropy and try to solve a specific problem within the astronomical community that Astropy itself might not solve explicitly. And to make that a little more concrete, I can use an example. AstroQuery is an affiliated package which queries online databases for you. So if you want to query Sinbad or a Vizier, you can use AstroQuery to do that for you. And it uses Astropy in its backend to access those servers, in addition to lots of code that's particular to AstroQuery. So Astropy is both the core package and a broader effort by the astronomical community to join together and make one community effort-driven package. Who are the people who are doing all this work? Well, we are led by 4 fearless leaders. The Astropy Coordination Committee is Tom Oldcroft, Kelly Cruz, Tom Robitaille, and Eric Tallerud. They are in charge of coordinating and managing the project, so the broad effort, including the assimilation of new affiliated packages, and acting as kind of ombudspeople of a sort within the core package, and now critically managing finances for the project, which is relevant now more than ever, now that there are finances to be spoken of. Then there's the Astropy team, which you can find at astropy.org/team.html, which is a much larger group of people, although a lot of the names on the previous slide appear in multiple roles on this slide as well. The Astropy team is made up of people who are volunteers historically within the Astropy community who are working to complete tasks that need to be done within the Astropy project. And you can see what some of those are. There's an official ombudsperson who is Steve Crawford. There's a Google Summer of Code coordinator, Brigitte Suboc. There's a whole bunch of other roles that I encourage you to go check out and to interact with the people who are in charge of these other roles. More importantly, Astropy, if it isn't already you, it has the opportunity to be you. Astropy is developed actively by many, many committers. If we look on GitHub at the commits coming from the many people, I believe it's now more than 300 contributors to Astropy, we find that there are some interesting trends in the commit history that you can access through the GitHub API. In particular, there's almost a linear number of commits that have been made over the past 7 or 8 years to the Astropy core package. If you look at the plot on the left, you see that the number of committers has a roughly power law distribution with number of commits. As astronomers, of course, everything is a power law, and so why should we not also behave as a power law? You can see that this plot tells you that there are a few committers who generate a lot of commits and a lot of committers who generate a few commits. And lastly, in committers per month, you can see that the number of contributions, or the number of contributors, has sort of equilibrated over the last few years to a roughly constant level after ramping up in the first few years of the project. Now, suppose you are hearing about Astropy for the first time and you want to get involved. How do you get involved? Where is Astropy? Astropy mostly happens on GitHub. GitHub, if you're unfamiliar with it, is a tool for sharing and controlling versions of software, or really any other diffable document, on the web. And GitHub allows you to create an account for free and start creating contributions to open source projects like Astropy. So if you go to github.com/Astropy, you will see the Astropy project's landing page, which has as you can see, a bunch of packages, not just Astropy core, but also some of the affiliated packages which are controlled by the Astropy project. And you can see that a lot of these repositories are very actively contributed to. You can see that Astropy was near the top of the list, which reflects how recently it was committed to, and SpecUtils is under heavy development at the moment. One of the core principles of Astropy is open development, and I want to take just a moment to define what that means. Open development is slightly different from open source. To be open source, you have to share your source code and make it clear how it works so that other people can access it and tweak it if your license allows them to do that. Open development is slightly different. Open development means that everything that's plausible to be done in the open should be done in the open. In other words, when you make a major decision about the design of Astropy, when you propose a new feature, when you try to fix a bug, when someone needs to update the documentation, all of that should be done in public on a freely available platform, which for us is GitHub. Open development has several advantages. It allows users to become contributors at their own pace, and most of us who have spent time contributing to Astropy can attest to this. We often get started on our own and without necessarily a direct invitation from someone to join Astropy. Although if you need a direct invitation, let me be the one to extend it. Please join the Astropy contributor community. But it also, more importantly, is the key to sustainable parallel development of Astropy core and the affiliated packages over the several-year horizon. Open development allows users to suggest new features, allows other contributors to contribute those features. It allows bug fixes to be caught and made as fast as possible. And it allows for multiple people to be working on the project at the same time in parallel. To quote Eric, Astropy is a duocracy. And I like this quote because it reflects the idea that the work that gets done is the work that you do. This is a bit fraught in that the people who have the most time to do that work often have that time for various reasons. And if you find yourself not able to give that time, we are still forever grateful for any contributions that you can make, including raising issues on the GitHub issue tracker. Writing code for Astropy is not the only way to contribute to Astropy. And so we are grateful for any contributions you can make. Here's what Astropy core looks like. Astropy core has more than 25,000 commits the last time I checked when I made this talk. It has more than 300 contributors, and if you look at where they're from all over the world. There are currently more than 900 issues, which I think is a good sign. There's definitely a healthy and unhealthy number of issues. I think a number of issues this large reflects that there are many users finding many improvements that can be made to the software in real time, and that's exciting to me. And you can see, importantly, there are more than 50 pull requests at the time that I took this screenshot, which indicates that there's very active development happening from many developers, again, around the world. I've mentioned a few times this concept of affiliated packages, and I want to highlight them again. The idea of an affiliated package is that it relies on Astropy to solve a problem. It's optimized to reuse existing open source software. It encourages the interoperability between existing open source software, and it meets the interface standards that Astropy sets out in its code guidelines. This is one of the central ways that we minimize the duplication of effort. Rather than having 10 people write 10 unique software packages that do essentially the same thing. The purpose of affiliated packages is partly to say, we want to rally our efforts behind one central project related to each task that needs to be solved. And if I can introduce my own quote to the canon of the duocracy, I like to think of affiliated packages like states, in that they are the laboratories of duocracy. They are where we experiment and create and freely contribute with or without the guidance or direct support from the Astropy project, which we can then seek explicitly later on. There are a lot of really useful affiliated packages, and I encourage you to get to know them. Here's a small sampler of a handful that I use. They are available at astropy.org/affiliated. And if you go to the PyAstro schedule, you can find a link to this talk where there are links to each of these packages within the talk. To give you an idea, this is what the weekly pip install figures look like for a bunch of Astropy affiliated packages chosen somewhat randomly from the affiliated package website. And you can see that there's a wide range of use, which is generally increasing. Hard to tell on the log scale, but they're generally increasing for most of these affiliated packages. And so this is where the people who care about X-ray spectral timing can work on Stingray and consolidate their efforts there. The people like me who worry about AstroPlan, which is for planning astronomical observations, can try to focus efforts there. One of the questions that we get asked about a lot is, how is Astropy sustainable, or how can we ensure that Astropy is sustainable? And of course, one way is because of you, all of you contributors who work so hard to make Astropy what it is are the reason why Astropy is sustainable. We could not do this without you. However, money also helps. And so there's recently been a grant that we successfully were awarded by the Moore Foundation. And if you have further questions about this after I'm done giving a brief plug about the Moore Foundation, I encourage you to read up this NumFocus blog post, which tells you some of the details about the Moore Foundation grant. It is a $900,000 grant aimed at improving the governance, sustainability, and inclusivity of Astropy. The Astropy Coordination Committee and subcommittees are in the process of creating a structure that will govern how the grant is dispersed from here on. There's a finance committee in the process of being formed, which will work out the contracts and the policies regarding who gets to travel off of this grant and other concerns like that. The focus for getting people paid right now is focused on getting people who have already volunteered large sums of time on the project, getting them paid as soon as possible. And then we will broaden that scope over time to seek to recruit new people. And lastly, there's a goal within the community to go for radical transparency, which means there will be an effort to make everything public that can be made public, so that when the governance and finance committees meet, they can share notes about what they met about and what they decided. Anything that's not confidential will attempt to be shared as rapidly and transparently as possible. And then on the technical side, there are a bunch of tools that keep Astropy sustainable. And if you haven't come into contact with these tools, I encourage you to check them out for your own research as well. The things that scale up to the Astropy size project also scale down fairly well, and I find that they're very useful in my research. Some of those tools include continuous integration tools like Travis CI, CodeCov, and Circle CI, which allow you to make sure that new updates to Astropy or your code don't break the existing software. They allow you to make sure that pull requests coming in have their own tests and that those tests pass. And they also allow you to check that your software is running on multiple operating systems correctly with different combinations of dependencies. This can be a real nightmare to manage if you've ever tried to coordinate use of your own code across Windows and Mac and Linux and didn't know in advance if it was going to work when you make a change on one operating system on the other operating systems. There are straightforward ways to check that using these continuous integration tools. Another really helpful tool is Read the Docs, which allows us to write documentation within the code and then have that documentation build itself into a website, which also builds a PDF document that you can read and search to find the functionality and tips and tricks for how to use Astropy on the web. Of course, we would not have Astropy if it weren't for the contributions of human code reviewers on GitHub. And so we are forever indebted to the people who bravely and selflessly allow part of their time to be given to checking that your code meets the code style guidelines and sanity checking the contributions that you made and making sure that nothing malicious makes it into Astropy. And of course, we are indebted to you, the contributions from more than 300 people of all career stages could not have been done without help from people like you, so thank you. And whether or not it's sustainable, it has an excellent citation record so far in that the Astropy paper gets cited pretty much every day, which is really exciting to me. I want to take the last few moments of my talk to point out some tools that you might not have explored fully or you might have heard of but not used, which reflect Astropy's efforts to remain sustainable. One is the documentation. Astropy is nothing without its documentation, because if you can't figure out how to use the software, then what good is it? And so people have spent a lot of time writing tutorials, writing detailed instructions for how to use Astropy, and documenting every feature and function within Astropy. In order to find that, go to docs.astropy.org. I will take my moment at the podium to say that it's actually very readable. If you've ever tried to read the docs for fun, because yes, I've done that, quarantine life is very different from my normal life, there's actually quite a bit of useful information in there, which has taught me how to do some things in astronomy in addition to with software. Next, there's learn.astropy.org, which is soon to be updated with a major overhaul. We recently hired a contractor who is working hard on refreshing the Learn Astropy webpage, which contains tutorials, documentation, and examples on how to use Astropy and its affiliated packages to do specific astronomical tasks. Of course, comprehensive testing is integral to the sustainability of Astropy. The way this works might be a little intimidating the first time you see it, and so I want to kind of demystify what this chunk of a GitHub pull request looks like if you've never explored the details buttons before, which is at the bottom of a pull request when you create your first contribution to Astropy. There are many checks that get run hopefully, if you're either very smart or very lucky or both, all the checks might pass. And that's what happened on this particular pull request. The checks make sure that the code does not break previously existing code, make sure that the documentation can be built successfully, and make sure that the code runs on several operating systems. And the tests are integral to making the Astropy project work at the scale that it works. To quote Kelly Cruz, tests are, show me your tests is the show me your error bars of the 21st century. And I'm very proud to say that Astropy has loads of tests. You should go see them. Astropy is also a project that seeks to create new users and turn those users into contributors. We do that at a variety of different events that happen around the world throughout the year. At the AAS, there's a Astropy workshop where we take the time to introduce you methodically through the package and some affiliated packages. And then a newly available service is there are a handful of people who can go around giving Astropy workshops at smaller venues. And so if you would like to have an Astropy workshop at your institute, give me a shout or shout out to the Astropy Coordination Committee and see if we can get a representative from the Astropy team to come give a workshop at your institution. And finally, this is my last slide. Astropy is a community that works because it communicates. And one of the ways that we communicate is on Slack or Matrix. Pick your poison. The easiest way to get started is to go to joinslack.astropy.org, which will invite you to the Slack channel, to the Slack team, which contains many channels which have discussions ongoing about the development of different components of the Astropy core package, the Astropy project as a whole, and some affiliated packages. And if you ever have any questions or thoughts or comments or concerns and you'd like to reach out to me, especially about ways to improve this talk, I encourage you to reach out to me on the Astropy Slack team. I'm going to stop there and thank you for your time.
That's fantastic. Thank you so much for taking your time out to speak to us, Brett. We appreciate it.
Of course.
So I'm going to pass it over to questions. I'm just having a look at our top Q&A channel, and I don't see anything there at the moment. Is there anyone online on Jitsi that has a question? I actually have a question for you. So I think you made a really, it was great to see kind of how to get involved with Astropy, and I think that's a really important part about PyAstro is welcoming new people to the community and encouraging them to get involved. How did you get involved with Astropy? I think people will be interested to hear some of the newcomers. How did you get involved personally?
Thanks for your question. I got involved as a student when I was a graduate student at the University of Washington. I wanted to start working in the Astropy world and wasn't sure how to go about doing that, but heard about a program called Google Summer of Code. And I didn't give a shout out to that program in the talk, so I'm really glad you gave me the opportunity to mention it now.
Excellent.
Google Summer of Code is a program sponsored by Google to allow open source software communities to fund interns to work on their projects over the summer. And Google will essentially pay a stipend to the student for the open source software project, given a somewhat complicated selection process. And I participated in the Google Summer of Code in 2015 as a student first, where I developed with a collaborator the Astroplan affiliated package. And after that, I was a mentor for 2 summers through the Summer of Code program and have been contributing to Astropy ever since. And I think I want to emphasize for the people who might be making their first contribution to Astropy that no contribution is too small. The most common contribution that I make are typo corrections to the docs and to the website, and I am not ashamed of that. Every contribution counts. So correct those typos, because every pull request is an opportunity.
Definitely. Every little bit, right?
Yeah.
We now have another question for you. So from the Talks Q&A, any big plans in the Astropy project, the Astropy library in particular, in terms of new features or refactorings?
Fun question. The conversation around major feature improvements and updates to the core package mostly happen on Slack, on the Astropy dev listserv, which you can access through the Astropy documentation, and through a mechanism called APEs, which I believe is the Astropy Proposal for Enhancement, or an APE. And so I encourage you to check out on the github.com/astropy page the APEs repository, which contains the proposals for enhancement, which are the place where big recommendations are made about big shifts that are happening within the project as a whole.
Brilliant. Thank you very much, Brett. So I'm going to suggest, because I think people might, in different time zones, wake up and watch this later, maybe people could get in touch with you or post questions, and we can let you know about questions later on today if there's any more. Does that suit you okay?
Yeah, that'd be great.
Perfect. Well, thanks again for speaking to us. So that's our first talk of the day done. So if you want to meet me back here, everyone, on the hour, so in about 30 minutes, we'll have our second talk of the day about SKA. So talk to you all then.
Thanks.
Thanks, Brett.